Hello everyone, welcome to yet another video of Tinchika Insights. Today we are going to look at K8sGPT integrations. Particularly, we will be looking at KEDA integration. KEDA is Kubernetes-based event-driven autoscaler. To put in simple terms, KEDA helps you to scale your containers based on various parameters within the cluster. The scaling could be based on the CPU usage of your container, the number of messages that are there in a queue, and various other things. If you're interested to learn more about KEDA, I'll leave the links to learn more about KEDA in the description. Today's focus is on K8sGPT integration with KEDA, so I'll just focus on that in this video. Let's get started. All right. First, let's look at how to enable KEDA integration with K8sGPT. In order to do that, we need to use the K8sGPT integration command. Let's look at integration. So as you can see, the integration command has various subcommands like list, activate, and deactivate. So in order to look at all the integrations that are available with K8sGPT, let's type in K8sGPT integration list. So you can see that these are the available integrations with K8sGPT. You can see KEDA down there. You can also see that there are various other tool integrations available like trivy, which is a vulnerability scanning tool, Prometheus, the monitoring stack. And in fact with AWS as well as Kibana. Kibana is a policy management tool. So all these kind of integrations are available. We are going to look at KEDA today. So let's activate the KEDA integration. So as you can see in the default cluster, this is K9s console. In the default cluster, in the default namespace, we don't have any workloads running as of now. So now let's see what happens when we enable or activate the KEDA integration. So this is the command to do this. So you can see a release got installed. So this is a Helm install that was done. And as a result, you can see that all the KEDA related containers start running in the default cluster. So all these containers are related to the KEDA operator assets. So since KEDA operator was not found on the cluster, K8sGPT installed these KEDA operator into the cluster. All right, so all the KEDA related pods are up and running now. Let's try the integration list again. Okay, as you can see, the KEDA one is active now. So this shows that KEDA is active, and now you can actively query KEDA related objects using K8sGPT. In order to see the K8sGPT usability with KEDA, we need some scaled objects available in the cluster. So right now I don't have any scaled objects in the cluster, so I'm attempting to create one. Okay, so let's look at this KEDA demo YAML right here and what objects we have in it. All right, you can see that so there is a deployment right here. So this is command demo deployment, and it contains a command demo container. This is a Debian image container. I simply have a while true while loop is an infinite while loop here just to bump up the CPUs. So you can see that the request is 500M and limit is 500M in this deployment container. And this is a scaled object that we will create. So it is set as a CPU scaled object. We'll target it in the default namespace assets. There will be a minimum replica count of 1 and max replica count of 3. And the metric type that is allowed is utilization, which simply says that if the utilization of the container goes to 50% or more, simply scale the container. So essentially, when I deploy this, what would happen is we will simply notice that the number of containers running would be 3, right? So that is what this would do in the backend. So let's try to apply this. All right. So you can see that the deployment and scaled object is created now. So let me go into the cluster and see. Okay, sure enough, we have one command demo running. As you can see, there is a scaled object, CPU scaled object here right now. Okay, you can see that this pod is slowly scaling up. Let's look at the HPAs here. So you can see that there is an HPA, KEDA HPA that was created by the scaled object itself. So now you can see that the minimum pod is 1, the max pod is 3, and the replica's target is 2 now. Okay, so slowly, as and when the metrics calculations progress, you can see that the number of replicas are getting bumped up, right? That is because you can see that there is a 100% utilization and 50% is your target, right? So since our the CPU is completely used, 100% used in these containers, it is immediately bumping up the container count. So now we should be running in 3 replicas. Let's look at the pods now. Yeah, sure enough. So we have 3 pods running, which are completely utilizing the CPU. So let's try out, coming back to K8sGPT, let's try out K8sGPT command again. I'll just use the analyze command here. All right, so right now there is no errors being reported from any of the scaled object. We don't have any problems as such reported on the scaled object. So if we are to demonstrate a fault in the scaled object, I am simply trying to going to create a fault for now to show how this works, right? So let's go into the deployment. So as you would have noticed earlier, let me show the object once more. So in this object, you can see that in the scaled object, the target of the scaled object is command demo, right? Command demo is your deployment right here. So if we remove this deployment right now, essentially there is no scaled object. And there is no target for the scaled object. So we wouldn't notice anything bad in the cluster if we do that, but it will simply be silently failing. But let's see how um, K8sGPT would help here. So I'm going to delete this deployment. As you can see, command demo is the deployment that I'm going to delete. I'm simply deleting this deployment right now. So as you can see, if I look at the scaled objects, you still have the scaled object, all the triggers, everything is in place. You have the target name, everything in place. So you don't have any other conditions here within the scaled object. So let's see, let's try to run the K8sGPT analyze again. K8sGPT analyze. All right, now this shows us some value, right? So basically it immediately says us that the scaled object uses deployment command demo as scale target, which does not exist. Okay, let's try to do and explain, which will explain and give us some solutions for this, right? So that is K8sGPT's power here. So let's try with local AI as backend. So I'm having a local AI Olama service already running in my local, so I'm just using that. Okay, all right. If you see this, scaled object uses a command as scale target, which does not exist. If you look at the solution, it immediately says you to check for a deployment named this, whether it exists in the cluster. If it does not exist, create a new deployment with this name using kubectl apply. So all these steps. So update the reference of the scaled object to the correct reference. So if I have misreferenced it, it is asking us to correct it. So possibly all this helps you resolve the issue here, right? Okay, so the other thing that you should notice is that currently all of these errors are reported all at once, right? So in a real cluster scenario, you might end up having a lot of problems reported all at once. Maybe all these different objects will start throwing errors in a real cluster, right? So in order to filter out particular objects when we do the K8sGPT analyze, we can use the filter switch along with the K8sGPT command. So let's see how that works. So I'm typing K8sGPT analyze again here, and I'm passing the filter flag, and I can simply type the scaled object here. Okay, as you can see, now it is only throwing the scaled object error, right? So we had service object error as well in the cluster, but it is simply throwing the scaled object error alone. So if I do the explain along with the filter tag, it will do again the same. Again, the explanation will be given only for the scaled object one. So as you can see, we still get the same explanation, but we only see the scaled object. So this is how you can filter things out so that you can analyze it much more precisely. Okay, so to see what all filters are available, there is this filter command which you can use to look at all the available filters. So you can simply type filter list, and you can see that there are a ton of filters that is already available. So you can see that there's all the default ones which appear in green here, and you have the blue one which is from the integration, right? So like this, if when you enable any integration, you will see that these object filters get added to this list, as well as in most cases the operators for that corresponding integration gets installed automatically into the cluster. I hope you got a very quick intro into integrations in K8sGPT and how it works with KEDA. Hope you enjoy this video. See you in the next video, and thanks for watching.